Science for Everyday Decisions, series by Center for Sustainable Development at the Earth Institute, Columbia University. For your consideration for a more sustainable life through education for sustainable development.
Start recording. So hi everyone, thanks for joining today. And super exciting. We'll continue with our Eco Ambassador series at 4 p.m. EST. There are many students who can't join today, so they will be able to see the recording and will be able to take the message that the presenters have for us today. So with that, I'll ask Will to introduce his students and their research. Will?
Thank you very much. So hello, everybody. My name is Will. I'm a high school teacher, and I work with the school's research program. And the philosophy behind this program has been that regardless of age, regardless of background, every student has the potential to conduct real science research and then utilize that research to bring about lasting and impactful change to the community. And so that's always been our philosophy and our mindset. And my hope has really been to accelerate the growth of our next generation of future science and social leaders. And this year, I've been very, very lucky to have a cohort of really disciplined, ambitious, passionate, and professional students. And working together, you'll see that they were able to connect with Brookhaven National Labs with the goal of conducting a human health project involving analyzing pollution levels in commercially sold fish. And what the takeaway here is, and you'll see in their work, was that these students with an environmental and human health mindset really conducted research that very few sophomores and very few juniors in high school are really able to experience. And they were to leverage these contacts and leverage their effort and energy and really come away with some findings that I found to be very eye-opening. And these findings, I feel, set the stage for some really potentially meaningful community interventions. So with that said, Erin, I think you're presenting or you'll be sharing your screen.
Yes.
And then, all right, guys, it's all yours.
Highschool, a student-led exploration into bioaccumulation of pollutants in commercially sold fish as a public health issue.
Who we are. We are ambitious and research students determined to solve many of the world's challenges and improve the condition of our environment by building research and community connections to advocate for human health, the environment, and we hope to use natural science to make a positive impact on our society.
Disclaimer, we need to conduct further research and our results are pending official review. Background. Heavy metals can be toxic and are often associated with health risks. Heavy metals can damage and alter the function of many organs, including the brain, kidneys, lungs, and liver. They are also associated with physical and neurological degenerative disorders. In an industrial world, using coal for energy can allow heavy metals like mercury to accumulate in marine environments. In a marine environment, it is possible for those inorganic compounds to come into contact with other organic compounds. Because heavy metals are found in water, we hypothesize that they may be found in fish. If present in fish, they pose a risk to consumers, and with our goal is to protect human and animal health, we need to know what is in the fish in order to know how to protect ourselves.
Procedures. We purchased fish and fish products that research suggested were at risk for heavy metal bioaccumulation. The samples were dehydrated and then affixed to mounts and exposed to 13.5 kiloelectron volts with a second round of 12.5 kiloelectron volts. We also used PyXRF to identify elements based on the peaks in the emission spectra.
The technique we used was XRF, or X-ray fluorescence. How this works is the sample is bombarded with high energy X-rays, and this causes electrons to be ejected. In order to fill this new vacancy, higher shell electrons fall to fill this vacancy, and as they fall to a lower energy level, they release high energy X-rays, and by analyzing these X-rays that are released, we can identify the element. And we use a program called PyXRF that takes this raw data, makes it into a graph, as you can see here, and the peaks are the different elements.
These are pictures of us actually doing the work at BNL. On the left, we have Erin and Reem discussing how to read the emissions booklet with one of the BNL researchers to analyze the data further. And then on the right, we have a action shot of us actually analyzing the data using the PyXRF and looking at the peaks in the emission spectra to try and identify the elements. Then here we have again on the left, Erin and I conducting, moving the machine and learning how to use the controls to drive the actual NSLS2 beamline so we could line up our sample properly and get the best results. In the cat food, we found many interesting findings. We found that multiple elements had accumulated in the cat food, one of the most alarming being zinc. Zinc is known to be extremely toxic to cats, and ingesting zinc can cause destruction of red blood cells, liver damage, kidney failure, and heart failure. Elements such as potassium, calcium, iron, nickel, copper, and titanium were also found in the cat food, but those are less alarming. Geranium and bromine were also found. Further research should be conducted to examine whether long-term consumption of these elements may cause cancer in the animals and may be one of the main reasons that many of our pets die at a young age from cancer.
Results for the yellowfin tuna. Many elements had accumulated in the yellowfin tuna. A few of those are argon, potassium, calcium, iron, nickel, copper, zinc, germanium, selenium, and bromine. Two of the most harmful elements that were found were mercury and arsenic. Long-term exposure to mercury can deteriorate the nervous system, impair hearing or vision, and cause tremors. Long-term exposure to arsenic has been linked to cancer, cardiovascular disease, and diabetes. Therefore, we need to conduct further research to see if either of these have links from can link eating fish to developing any of these diseases.
Results for the tilapia. Multiple elements were found in the tilapia fish. These elements found in the tilapia sample were argon, potassium, calcium, scandium, titanium, chromium, iron, cobalt, nickel, copper, zinc, germanium, selenium, and bromine. Organic bromines can cause organ damage and possibly cancer. Inorganic bromines can damage the nervous system and the thyroid gland, but other than that, there were not really any harmful metals found in the tilapia.
For the albacore tuna, the elements of note were first bromine, which, as Reem said, can cause nervous system damage depending on whether it's organic or inorganic. We also have arsenic, which, as Erin said, is potentially carcinogenic and can cause other harmful health effects. And zinc and copper were of note here because it agreed with previous literature that said zinc, copper were found in wild-caught fish, which proved that the findings match. For sushi tuna, it was mostly the same elements, again, bromine and arsenic, and again, zinc, copper, and nickel were in agreement with previous literature on wild-caught fish. And for skipjack, again, it's the same. Arsenic was harmful, bromine's harmful, and zinc and copper are in agreement with previous literature.
Next steps. We need to conduct further research. This includes where the fish was sourced. Is it a local problem or an international problem? We also need to balance informing the public with potential for panic. We don't want to cause a panic in the world we are already in. Our results also need to be reviewed by the researchers that we worked with at BNL, and a larger sample size is needed to see if these results are consistent.
Outreach. The fact that heavy metals are present in these samples indicates that the FDA doesn't regulate the human food the way they should, and it wouldn't hurt to notify them about our findings. As eco-ambassadors, we can use this data to inform different companies that their seafood products contain heavy metals, and we could also advise the public that the fish they're eating may not be the safest for them. For the pet food, we can reach out to specific companies and even notify the pet store owners that they should take some of this food off the shelves to avoid potential harm in animal health.
Scientists, we learned about how spectroscopy works, and we also learned how to prepare and analyze samples using X-ray spectroscopy. We also learned how to operate the SRX beamline control console, and we learned how to interpret real spectroscopy data. We also experienced applying science to an environmental and human health project. Acknowledgements. Our work was made possible through the support of the following researchers: Dr. Jürgen Thiem, Dr. Vivian Stojanov, and Dr. Lita Perez.
Thank you. Any questions?
Thank you. I think this was great to hear your research, and just some background questions. How did you come up with your research question, and then how did you come up with the methodology to actually investigate it into your research question? Did you do a lot of reading to understand which method would be useful to inspect this particular question, or did you actually approach the researchers you had mentioned in your acknowledgement and they gave you suggestions on the methodology?
We did a lot of reading on bioaccumulation of heavy metals in different seafood, and then with our connections at Brookhaven and the help of these researchers, we determined that the NSLS2 beamline would do exactly what we wanted to determine what metals were actually in the products that we wanted to look at. Because I know Erin and I want to look into something along the medical cancer portion, and we determined that heavy metals are a really big carcinogenic factor. So looking into these could help us advocate for the environment, human health, and look into the background of carcinogenic agents.
Thank you, Kaitlyn. I think Ayan has a question. Yes. Yeah.
So I was just wondering, where did you get the information from, which fish to experiment on, in the sense, because how do you know which fish species contained the most of these bad materials?
Based on the research and readings that we are doing, we determined which fish were the most popular and which were suspected to have the most, so that way we could see for ourselves if it followed along with the literature, that if certain fish did have them, we inspected the fish that the research suggested would have heavy metals present.
Okay, thank you.
Any other questions? This question of heavy metals itself is, I think, is a very fascinating one, because usually people focus on plastic, and to get at the idea of heavy metals, I think is fascinating, because it's at least there is less of public knowledge about this particular topic. Usually we have this plastic, microplastic, microfibers. That's again quite a hot topic. But to use this heavy metal lens, I think is very, very interesting. I don't know if you had any suggestions for others who want to use this particular lens, or are there any gap areas that you see that you were able to highlight based on the research done so far?
Well, I think we need to further look into it with a larger sample size to make sure that our findings are completely accurate. I think we also, at least for my end of it with the pet food, I want to look into and compare the different brands to see if some of the higher priced brands will have better quality fish in it than the lower end of it. So we can see, is it all cat food? Is it all tuna? Is it all is there any specific kind of fish that it's definitely hands down the worst for? Because right now we just have a broad spectrum of knowledge, but we need to further look into it to see if there's any one fish or any one species or any one brand that we can pinpoint that's like, wow, they have a drastic amount of heavy metals and this one is a lot better for you.
Mm-hmm.
I think it would also be important to see where the fish are coming from, to see like if it's in certain areas, like is it a local problem here in the US on the East Coast, let's say, or is it an international problem? Like based on different levels of like industrialization, how the heavy metals get into water, I think it's important to see where they could be coming from, so where the fish with the heavy metals are coming from.
Mm-hmm. But your idea of using the most popular fish, I think, is very helpful, because as for a consumer, you are taking the fish that's most popular and most people are consuming. So I like that lens. It's more user friendly and it's more appealing to us as consumers, that okay, you know, tilapia I can relate to, other things I can relate to. So I think that was a very interesting lens to take in terms of making it your research much more approachable. Right? Great. Any other? Actually, can you go back to your slide on the first one, which was showing this pictorial representation with the mines and other things? And so I just wanted to
Which slide?
The first, I'll go back. I think it was one of your earlier slides. Yes, the one after this.
This one.
Yeah. So basically, based on your diagram here, the heavy metals are coming from coal plant and then mines and other things, right? That's your, based on the research that you've done, is that the main source of heavy metals in the fish?
Based on like the literature that we've read, we found that like industrialized factories that use coal, or also like mines, they're definitely a source of how the heavy metals could enter the marine environments, and definitely one of the ones coming from like coal plants or mines is definitely a possibility that mercury could be coming from like these industrialized places.
Interesting. Any other questions from anyone else?
You guys tested out cat food, so do you also have like a plan to test out dog food in a way?
With that, a lot of dog food doesn't contain fish, so it's not as suspected that there will be heavy metal bioaccumulation in there. I do want to look at certain brands of dog food that do possibly contain fish to see if there is a correlation between there being it in cat food and there being it in dog food. But we have to find brands that are specifically fish-based dog food, because heavy metals are really only suspected, or well, on our project line, we're looking at it in fish, and a lot of dog food is more based on like chicken and beef, and a lot of cats eat tuna and different types of fish.
Okay, thank you.
Maybe one graph of, I mean, you mentioned it in your research, like the different metals and their harmful effects. If you can, you know, include that slide also, because you said arsenic and, you know, other heavy metals that were found, they had certain medical conditions if you consume them in a lot of quantities. Maybe a slide which includes the metals as well as the diseases they are associated with, commonly known diseases. Of course, the research will keep evolving on it. Might be helpful also to include, so that they can match up the quantities. I like your graphs on, like, you know, if you have tuna, then you have all these other different, and then you have a graph on it. But then I keep forgetting on which metal is associated with what illness. I think that might be helpful to include. Though I know you mentioned it in your research, so we can always review the slides again. But this is fantastic research and fantastic start of something that can be very, very helpful at various, you know, county level as well as national level, as well as for FDA. Any other questions?
guess I have one. So I guess my gut reaction after seeing the presentation is, oh my goodness, I'm never eating sushi again. And I guess to what degree would that fear be founded? And maybe do you have any like information that might like assuage the general public who might be concerned over these preliminary findings?
Well, we still need to look into it with a larger sample size, and we need to make sure that this data is 100% accurate before we notify the public and cause like a little scare. But I mean, as long as you don't eat sushi like all day, every day, you shouldn't be at that great of a risk. It's just you have to watch the quantity of the sushi that you're eating and look into the quality. If it's right now, since it's still so preliminary, we don't know exactly how it's going to affect you. We have to further look into that more before we say like never eat sushi ever again, because that's like not something that we should do right now.
I think it's like mostly like the quantity of when you eat it, like the quantity of the metals. Like if you eat a large amount, I mean, you're obviously going to have more effects. But I think if you just eat a little, I don't think the effects will be that big. Like a lot of people eat sushi, but yeah, so like.
Yeah, we also don't have data on concentration yet, absolute concentration, because X-ray fluorescence just tells you presence in not insignificant amounts. So we don't have any data on actually how much heavy metal is in these fish. So further research is needed for that.
And then I guess another question goes back to you're working together as scientists, and so this being a team effort, what was it like working as a team as opposed to working as individual researchers?
Well, I think it's nice to work as a team because you can bounce different ideas off of each other. You could split up different lines. Like we have one big project line, but like a bunch of different smaller projects in it, like the sushi, the tilapia, the cat food, the yellowfin. So it's easier to tackle a bunch of things at the same time when you're doing a group, and then you could bring all your ideas together to come up with a stronger and more prestigious conclusion.
I think it's like Kaitlyn was saying, like it's really nice to be able to bounce ideas off of each other, but also like in the end, if I'm researching one type of fish and someone else is researching another type of fish, it's good to be able to compare our results to see like what fish might have more risks of accumulation of these heavy metals.
Awesome, thank you.
Can you repeat your wild caught versus the other variation, and what was the point that you were trying to make again? Sorry, just to reinforce the point.
I'm sorry, what did you say?
There was a slide on saying that whether it is wild caught versus others, or was it, what was the link between wild caught versus the other?
Oh, that was just, I just spoke that out loud. Well, wild caught fish, as of around 2016, wild caught fish only comprises about half of fish eaten today, and aquaculture comprises the other half, but most of the literature is only on wild caught.
I see. Mm-hmm.
What I just wanted to ask another question, and you know, this might be something down the line, but I just think it's really interesting on the pet food front. It's true that that market's not very regulated at all, right? And
no,
I know
the FDA, according to the FDA's guidelines, they say they do regulate it, but as we're seeing here, they clearly don't regulate it enough to know that there's zinc in their cat food that is really harmful and poisonous to animals. And the FDA doesn't really look into animals as much because like they see it as they're just animals, but the animals I feel like deserve the same advocacy as we do because they're eating metals we shouldn't be eating metals. So the FDA doesn't really look into it closely enough.
And one of the things you all mentioned was that you'd want to try to do advocacy with the companies who are producing the food with these findings. And my cynical self wonders, they probably already know, and they're just hoping other people don't find out. And I feel like the work you're doing could be really important to kind of spur that advocacy and and push them in a healthier direction. So that's exciting.
Yeah.
This is fantastic. So what is the next step with this? Are you going to get these results verified, or are you going to already compile it in a report format?
Well, we're going to try and get our results looked over by the scientists that we worked with at Brookhaven to make sure that they're 100% accurate. And then we will probably try and figure out a way to look into concentration if we can, and then we'll start advocating for the different like human health concerns and animal health concerns. And that's along down the line. Hopefully we can also get a larger sample size to validate the results better.
I think this is super fascinating and very, very important. Any tips for our young eco ambassadors on your research, and not just the research content, but anything else that through the process you've been able to find out, your ideas on how to address a research question, or the type of things that are required to take a practical research question and then reach out to different people who would know the answer? What is the process that you followed? Maybe some tips on how a research like this can be conducted by students, so that our eco ambassadors be able to follow some of the footsteps that you've discovered throughout the process.
I think just definitely like reach out to other scientists and researchers, and definitely have like a plan so you don't sound like unprofessional. Have a plan and then just introduce it to them, and hopefully they'll like let you do and help you with it.
I think another big thing is like to stay driven, like because you can do anything with hard work, and if you take your ideas, and even if some scientists don't like it, there's other scientists who will, and you have to remember that. And also it helps to build up a good resume so you look professional when you're presenting your ideas, because once you have a few things under your belt, people take you much more seriously, and you could make a bigger impact with just all the hard work and background knowledge. And once you connect with scientists and mentors, everything just comes together, and you can make your hypotheses like shown in work, and you can determine your actual results.
I also think it's important to not be afraid of having big goals. Like Brookhaven National Labs, it's a huge institution, but like once they saw what we wanted to do, once they saw we had a plan, they were very willing to let us do our research and to help us do our research. All of the scientists and researchers that we worked with were very supportive, and although it seemed intimidating at first, they're really just there to help you.
How did you approach Brookhaven? How did you know about it? And what was their response? Like, did you go there with like just research questions in mind? And how did you just approach them? Just so that, maybe others would be able to follow something like this.
Well, first we formulated a proposal and we submitted it to them, basically asking them if we could use their facilities, such as the NLS2 beamline, to conduct our work. And then once they read our proposal and they thought that it would be a good idea and a good piece of work to use their beamline for, they reached out to us and we set a date to go and to actually conduct our research, and they taught us everything when we were there. We had to take a really long training course online to learn how to use the facilities, to learn how to be safe in a lab. And once that was all done, we went and we got our IDs and we used the facilities, and we worked right alongside these scientists to conduct our work. And that's just, now we have our results.
That is fantastic, and it just requires a lot of initiation, a lot of initiative from your end, and persistence, as you said. So I think it's great that you were able to follow your passion and take this particular research and ask people about it. I think it's just a wonderful lesson for all of us. Are there any questions from anyone else? Great, great. Thank you so much for the presentation, and thank you for working on this presentation during your break and with all the other things going on and a lot of tension and a lot of anxiety. I hope it was a fruitful, session, and I hope that all our other eco ambassadors watching it will be able to take some of these lessons and not only just the research content, but your approach and your enthusiasm and use it for their own research work. I certainly have something to look forward to and take some of the tips that you've given here. So thank you so much, guys. This has really been super phenomenal and very inspirational.
Thank you.
Thank you. Bill, do you have any other last minute suggestions or anything else that you would like to add?
Oh, I guess on my end, then maybe they covered the data end of their project, and then I guess maybe on my end, I'd just like to maybe share some of like the experiences I took away from working with them, and just from my experience as a cohort. They're just absolutely incredible. Just the potential, and then as you said, right, the initiative, the energy, the enthusiasm. I know that they worked on this project on the side, late nights. They're working with each other. They're delegating and organized. They're helping each other out with refining the slides and the presentation, right? Even just logistically, right? There's this one time where it was a crunch time. We had to drive all the way out to Brookhaven National Labs to get their badges, right? And they're carpooling each other like all the way out east onto the site. And I thought, in my mind, it's very rare to have students demonstrate that level of ownership and that level of commitment to conduct research. And just seeing them really take a 2-3 hour commute all the way out east just to make this project happen, I found it to be very inspiring. And then on my end as a teacher, working with such high caliber students, it really just, it's eye-opening to basically, it's the need that we need to challenge students, right? We really do. Our role as educators is really to accelerate, right, their growth, right? To really just give them the freedom to explore and take ownership over research that they find interesting, right? And help guide them, right? So that their efforts and their findings can serve as a vehicle for social change, right? Both, to grow their skill sets, but also to grow their mindset so that they know that they have a place as real agents of social change. And overall, it's just been such a really humbling experience, right? That these students really do know more than I do. And you know what? That's great, right? Because, right, they're the ones who are going to take over the world ultimately, right? And fingers crossed, they'll leave it in a better place than we left it for them. So ultimately, overall, guys, thank you very much.
Thank you, Will. Tomorrow we'll be back again at 4 o'clock and we'll be hearing more of some fascinating research. Meanwhile, I'll also subscribe to our ED4SD, ed4sd.org website. We'll send the link over because we'll be getting a lot of calendar invites and we have a lot of events coming up. It will be easier if you subscribe because there we have our Zoom links, we have all our events posted there. So definitely come back 4 p.m. every day with a new research topic and a new discussion, and all of them are super fascinating. And thanks, Will, for organizing this one and leading this one. It's really been excellent and I learned a lot. Thank you so much.
Thank you.
Thank you.
Thank you.